Okay, good afternoon to one and all. So, in the previous lecture of this electrical machine first, we have discussed regarding EMF equation of the single phase transformer. Also, in the previously we have discussed regarding working principle of single phase transformer. So, in the EMF equation, we have derived the EMF equation, that is E is equals to, or ERMS, it is equals to 4.44 F phi m into En. Or if we write this equation for primary winding having an N1 number of turns and the induced EMF at the primary winding, it is equals to E or E1, then we can write the equation E1 is equals to 4.44 F phi m into En1. Like that, according to this, we have also discussed regarding transformation ratio K. So transformation ratio K, it is equals to N2 divided by N1, it is equals to V2 divided by V1, it is equals to E2 divided by E1, it is equals to I1 divided by I2, it is equals to K. Okay. So according to this, we have derived the transformation ratio also. Now, in this lecture, we will discuss regarding next one point is that types of transformer. So what are the types of transformer? How these types it will become into picture? Okay, so that means what is meant by transformer? According to construction, there are some types. According to that means according to voltage step up or step down, there are some types. We will discuss in details in this lecture. Now see, in the construction of transformer, there are main three parts of construction. First one is nothing but the winding of the transformer. Second one is nothing but the core of the transformer, and the third one is nothing but insulating material used in the transformer. Okay, so in the construction point of view, there are three main important part of the transformer construction. First one, the winding, that means a copper wire or it may be copper winding. Then second one is nothing but core, that is having a low reluctance path and magnetic material, low reluctance magnetic material, that is core, and the insulating material. So there are insulation, it can be provided in between primary winding as well as secondary winding. Insulation it can be provided in between the each and every turn also. Insulation it can be provided in between the core and the winding also. So that insulation it will also plays a more important role in case of transformer. Okay, so all of you understand there are three main parts. First one core, second one winding, and third one is that the insulation part. Suppose if we are considering our agriculture field transformer, आपला agriculture field चा जो आपण DP म्हणतो, distribution transformer, which types of insulation it can be used in these types of transformer? Can anyone tell me? Anyone? Which types of insulation it is used? Suppose this is one type of transformer. In this figure, this is one type of transformer having an core, winding, and insulating material. That is insulation. It is more important because insulation required from core to winding, insulation required from each and every winding. That means in turns of the winding. And also insulation it will be required from primary and secondary. So in case of our distribution transformer, that is agriculture field transformer, suppose 63 kVA transformer, which types of insulation it can be used? कोणतं insulation use करतो आपण generally? Any idea about that? Hello, any idea?
No, sir.
No idea. Okay, ठीक है. In case of our distribution transformer, we are generally using a mineral oil. Mineral oil use करतो का आपण?
Yes, sir.
Okay. So this mineral oil it will be act as a insulating material. Like, so that means this oil. Do you know that the transformer tank it will be totally fulfilled by oil? Okay, totally it will be fulfilled by oil. And this oil it will be act as a insulating material from the winding to winding also, from the core to winding also, and for turns insulation, there are some types of coating it can be used, like as a varnish, or it may be some types of coating it can be used. For the winding, it will be insulated from the core, or it may be winding, it will be insulated from each and every turn. प्रत्येक टर्न्स पासून वाइंडिंगचं इन्सुलेशन एक कोटिंग न प्रोव्हाइड केलेलं असेल, दॅट मीन्स or we are using small type of mica or paper types of insulation or cloth type of insulation. Okay, but generally in case of our distribution transformer, that is DP, in case of agriculture field, we are using as a mineral oil as a insulation from primary winding and secondary winding. Okay, see, in case of construction, I have tell there are three important part. So in that core it is a very most important part, because it is made up of a magnetic material having an low reluctance property, or it will produce a low reluctance material. What is mean by reluctance? Anyone? What is mean by reluctance?
Opposition of flux.
Okay, opposition to the flow of flux, that means reluctance. It is reluctance. It is nothing but opposition to the flow of flux having an low reluctance material. म्हणजे कमी reluctance material, minimum reluctance material, that means minimum opposition to the flow of flux. That means if the minimum opposition to the flow of flux, so the primary winding flux, it will be totally induces EMF in the secondary winding, or totally it will be linked with that of secondary winding. That means there are minimum losses if we use the material having an low reluctance material. Okay, so core it will be manufactured having a low reluctance material, and there are number of strip it can be constructed. So see here, it is number of strips it can be constructed. Suppose this one is the one edged strip, or it is rectangular strip. एक strip consider करा. This one is the second strip, this one is the third strip. म्हणजे अशा कोरच्या पट्ट्या असतात. So these strips are attached to each other and it will form a core. Around this core, there are winding it can be wound. So this is depends upon which types of transformer is there. So suppose we are considering a core type transformer. In case of core type transformer, there are winding it will be wound around that core. Winding it will be wound around the core. So this winding, it is nothing but it is a copper material. Okay, this material it will be insulated from a varnish, or it may be one type of coating, and these winding or number of turns it can be wound around that core. So this is the core and winding. And insulating material, suppose in case of there are paper insulation, or it may be mica insulation is there. So in between core and winding, in between winding turns, that means turns to turns, and in between primary winding and secondary winding, okay, there are insulation it can be provided. So this is construction related to that transformer. There are again some of the equipment it should be constructed like that. If there are big transformer is there are breather is there. Again one conservator tank is there above the transformer tank. Transformerचा जो काही tank आहे, suppose this is one of the transformer tank. Above this transformer tank, another one tank is there. So this tank it is called as conservator tank. What is the purpose of that conservator tank? Conservator tank चं काय purpose असतं? Suppose here it is one बघितलंय का transformer. If you have seen the transformer, then you people know. Here it is one pipe, and pipe is attached to the main tank of this transformer. Here it is one conservator tank, and the oil it should be filled in this main tank. That is main tank, it is totally filled. याच्यामध्ये जे काय oil fill केलेलं असेल, it is totally filled, and the conservator tank it is half filled. Okay, conservator tank it is half filled. So what is the purpose of that conservator tank? Anyone from A division? Because we have already covered. What is the purpose of conservator tank, and it is why it is half filled? Yes, anyone? From A division student, what is the purpose or what is the function of conservator tank, and why it is half filled by oil? I have already told in case of three phase as well as in case of single phase. Hello, anyone from B? Okay, see, this is half filled, the function of conservator tank. So this will be half filled because of if there is a expansion and compression in the oil. Okay, if the temperature of the winding it will be increases, so oil it will be absorb that temperature or achieve that temperature. Due to that temperature there is a expansion in the oil. If the oil get expanded, so this expanded oil it will be occupy this area. Okay, it will be occupy this area so that it is half filled. And if the oil get compressed in the main tank मतलब जर oil compress केलं, then or the oil it should be compressed in the main tank. At that situation, to fulfill the value of this tank, that is main tank, the oil which is present in the conservator tank, it will be flows via this pipe through the main tank. That means main purpose of this conservator tank is that to maintain the constant oil in the main tank. ओके, म्हणजे मेन टँक मधलं जर ऑइल कमी झालं तर कन्झर्वेटर टँक मधलं ऑइल त्या मेन टँक मध्ये आलं पाहिजे. इफ ऑइल गेट एक्सपांडेड, ऑइल जर एक्सपांड झालं, इफ वी हॅव नॉट प्रोव्हाइडेड कन्झर्वेटर, इफ द ऑइल इट इज एक्सपांडेड, at that situation there is a damage to that of main tank also because of expansion, so that the conservator tank it will occupies, or the oil expanded oil it will be occupies the area which is empty in case of conservator tank, so that it is the function of conservator tank. So like that, another equipment, if the big transformer is there, there are some cooling method, or it may be cooling equipment it can be used. So cooling equipment like a fan, or it may be air cooled transformer. Then sometimes it is force cooled transformer, sometimes it is radiated cooled transformer. So this part you people will study in your third year in electrical machine design subject. Okay, so this is related to construction. Now the types of transformer, today's point of discussion is nothing but the types of transformer according to construction. What I am telling, see, according to construction there are main two types of transformer. So first one type, it is nothing but core type, and second one is nothing but cell type. Okay, so transformer it is divided into multiple types, or it may be it is divided into some types. So in that, according to construction there are main two types. According to construction there are two types. First one is nothing but core type transformer, second one is nothing but cell type transformer. First one core type, second one cell type. Now according to the phasing there are again two type transformer, that is single phase transformer and three phase transformer. Getting what I am telling? All of you getting? No? According to phasing there are two types, that is single phase and three phase. Now according to their application there are again two types of transformer. See, according to construction there are two types of transformer, that is core type and cell type. According to phasing there are two types of transformer, that is single phase transformer and three phase transformer. According to application there are two types of transformer, that is power transformer and distribution transformer. And according to voltage level there are two types of transformer, one is step up transformer and one is step down transformer. Okay, so see, all of you understood the types of transformer. According to construction there are two, core type, cell type. According to phasing there are two, that is single phase and three phase. According to that means application, there are two types, that is power transformer and distribution transformer. And according to voltage level, there are two types of transformer, that is step up transformer and step down transformer. Now see, we will discuss one by one. And according to the measuring instrument, or it may be according to measurement purpose, there are two types of transformer, that is potential transformer and current transformer, that is PT and CT. Okay, potential transformer and current transformer. Okay, now we will discuss regarding constructional part. So these are the main two types of transformer, that is core type and cell type. Why it is called as core type, why it is called as cell type, what is the difference between that? Okay, so we will discuss this one. Now, types by design or types by construction. Transformer differs in the manner in which the primary and secondary coil are provided around the laminated steel core. According to the design, transformer is classified into two types. Okay, so according to construction or its design, there are main two types of transformer. There are main two types of transformer. First one is nothing but the core types of transformer, and second one is nothing but a cell type transformer. Now see what is the difference between that. Why it is called as core type, why it is called as cell type. Okay, see, in core type transformer, the winding are given to considerable part of the core. See, this figure shows that the core type transformer. This figure, it will be shows that the core type transformer. In that core type transformer, the some part of the core, it will be encircled by the winding. Okay, so what I am telling, see, suppose this is a transformer. This is called as a हा जो काय part असेल कोरचा, this is called as a limb. Okay, and winding, it will be wound around the limb. The limb भोवती काय केले असेल, winding wound केले असेल. Okay, see, in case of core type transformer, the winding, it will be encircles the core. Sentence लक्षात येते का माझं? Winding or some portion of the winding, it will be encircles by the core. See, these are the core. This one is the core, transformer core, or I will write here 2D diagram of that transformer. Suppose this is a core, and some part of that core or winding, it will be encircles the part of core. कोरच्या भोवती वाइंडिंग आहे का वाइंडिंगच्या भोवती कोर आहे? Yes, give me reply. कोरच्या भोवती वाइंडिंग वुंड केलेला आहे की वाइंडिंगच्या भोवती कोर वुंड केलेला आहे?
कोरच्या भोवती वाइंडिंग.
Okay, so this is the main difference between core type and cell type. So see, in case of core type, winding encircles the core. म्हणजे कोर भोवती आपण काय करतोय, वाइंडिंग वुंड करतोय. वाइंडिंग encircles the core. All of you keep in mind. So this is most important part. That is, in case of core type transformer, the winding, it will be encircles the core, or winding, it will be wound around the core or around the limb. Limb किंवा core भोवती काय केले असेल, winding wound केले असेल. Now the coil used for transformer are former wound and are of cylindrical type. So this coil, whether it is all or cylindrical type, or it may be it is formerly wound. Cylindrical type असू शकते, or it may be it is a formerly wound. Such a types of transformer, it is applicable for a small size and large size transformer. These types of transformer, it is available, or it may be applicable for a small size as well as for a large size of transformer. So in case of small size transformer type, the core will be in the rectangular shape. All of you keep in mind, this is a one MCQ question. In case of small size transformer, normally the core, it is wound like as a rectangular shape. and on that rectangular shape the coil it can be wound on the cylindrical shape. लक्षात येते का बघा. So in case of small size transformer, जे transformer small असतील, so small size of transformer core it is made up of a rectangular, or the shape of the core it is a rectangular shape, and around this rectangular shape the winding, or we can call it as a coil, it can be wound on the cylindrical shape. Coil काय केलेली असेल, cylindrical shape मध्ये wound केलेली असते. So see, according to this you people find out the difference between core type and cell type. See, the figure below shows that the large size type, you can see that round or cylindrical coil are wound in such a way that is to fit over a circumference core section. Okay, see in this figure, these are the cylindrical core. Whether it is cylindrical core, no, these are the cylindrical winding. So this cylindrical winding it can be wound around the core. Coreच्या भोवती काय केलेले, cylindrical winding wound केलेले, and it will be fit over all over circumference of the core. कोरचा जो काय circumferential area असेल, so around this circumferential area the winding it will be wound. So in case of circular cylindrical coil, they have a fair advantages. What is the advantages to wound the coil in the cylindrical format? Okay, circular cylindrical format, having an good mechanical strength. So this is one MCQ question. All of you note down this. That is the advantages of cylindrical, that is circular cylindrical wound of the coil. It is nothing but it is having a good mechanical strength. So coil ची जी काय mechanical strength असेल, so this mechanical strength it is the good. The cylindrical coil will have a different layer, and each layer will be insulated from the other with the help of material like paper, cloth, mica, board, and so on. Okay, see बघा, याच्या भोवती जी wound केलेली winding आहे, we have generally using a, suppose we are using a cylindrical type of winding. So this winding, cylindrical winding or one turn, these are insulated from each other. प्रत्येक टर्न्स पासून पण ते इन्सुलेट केलेलं असेल. Also it is insulated from the core also. Core पासून पण इन्सुलेट केलेलं असेल. So for insulation purpose we are using either a material like a paper, that is insulating material like a paper, cloth, or it may be mica. So if you seen the disassembled winding motor, म्हणजे जर जळालेली मोटर बघितली असेल, ती जर रिवाइंड करत असतो त्यावेळेस आपण पेपरच्या स्ट्रिप यूज करतो ना. as well as the fitter it is also using some part of cloth पण यूज करतात. So these types of insulation is there. This is the insulation, that is paper, mica, or it may be cloth type of insulation is there. And the conductor, or we can call it as a wire, this copper wire, it is polished or it may be varnished. त्याच्या भोवती कोटिंग असतं बघा. So to make the connection I want to remove the coating on that coil. त्या coil वरचं कनेक्शन किंवा त्या coil वरचं कोटिंग काय करावं लागेल, रिमूव्ह करावं लागेल. So that means these are insulated by using a coating or it may be varnish. Okay, so material it will be used like a paper, cloth, mica, and so on. So this general arrangement of the core type transformer with respect to the core is shown in this figure. या figure मध्ये जे दाखवलेलं आहे. So this is the general arrangement of core type transformer. Okay, core type transformer. Okay, normally how the winding it can be wound. So the LV winding it is wound nearer to that of core. कोरच्या जवळ किंवा कोरच्या भोवती पहिल्यांदा LV winding wound करतो आपण. Okay, and above that LV winding we are using the HV winding. Okay, above the LV winding, above the LV winding, the HV winding it can be wound. त्या LV winding, HV winding भोवती, sorry, LV winding भोवती HV winding काय केले असेल, wound केले. So see in this figure here it is shown the different layer. So layer it will be like this. This is the core. हे core आहे बघा, कोरचं स्ट्रीप आहे. Around this core strip, there are some of the insulation, that is LV insulation, it can be provided. Above that insulation, this part, it is nothing but this is the winding, like LV winding. Okay. Above the LV winding, again there is a insulation, it can be provided. So this is nothing but HV insulation. We can call it as HV insulation. And above the HV insulation, there are HV winding, it can be wound. Okay. HV winding त्याच्यावरती काय केले असेल, wound केले असेल. So this is related to core type transformer. In that core winding, it will be encircles the winding, it will be wound around the core, so that we can call it as a core type transformer. The low voltage winding are placed nearer to the core. Low voltage winding जे आहे, it can be placed nearer to the core, and the HV winding, or HV winding, it can be wound. HV winding, it can be wound around this LV winding by putting some of the insulating material in between HV and LV, that is high voltage and low voltage winding. Okay, so to produce a sufficient insulation between winding, we are not wound HV winding around or nearer to that of core. कोरच्या जवळ आपण HV winding wound करत नाहीये. Above the core, there are LV winding, it can be wound by putting some of the insulation, and above that LV winding, by putting some of the insulation, we are wound a HV winding. Okay, see here sentence is given, the low voltage winding are placed nearer to the core as it is the easiest to insulate, or it is easy to insulate between core and LV winding. The effective core area of the transformer can be reduced. Effective core area of the transformer, it can be reduced with the use of lamination and insulation. With the use of lamination and insulation. So this is related to core type transformer. This is related to core type transformer. Okay, all of you getting? Just give me reply. काय doubt आहे का? Why it is called as core type transformer? Is there any doubt?
No, sir.
Okay. If we understood, we discussed the cell type transformer, then you are easily understood both what is the difference between these two, and why the core it is called, why the cell it is called. So there are main one difference. I have already tell main. There are multiple difference other. Okay. See, in a cell type transformer. So this is the cell type transformer diagram. Okay, this one is the core type 2D diagram here drawn. 2D draw केले बघा. This is the core type transformer. So these are the core strip. It is the rectangular strip, and this is the limb. So winding, it can be wound around the limb. That is winding, it can be wound on the first limb, that is primary winding. Secondary winding, it can be wound on the second limb, that is secondary winding. Okay, that means winding, it can be wound around the limb. And in case of core type, the winding, it will be encircles the part of core. Core चा जो काही part आहे तो winding न encircles केले. Okay, now see, in case of cell type transformer, the core surrounds a considerable portion of the winding. So this is the main difference between core type and cell type. The core, it will be surround the considerable portion of the winding. All of you draw this diagram of core type transformer. बघा, ही core type cell type transformer ची diagram आहे. So there are three limbs. This is the one limb. This one is the second limb, and this one is the third one limb. So in case of cell type transformer, there are three limbs, and winding, it can be wound around the third limb. Sorry, around the middle limb. Okay, जो काय middle limb आहे याच्यावरती काय केलेलं आहे, winding wound केलेलं आहे. both the primary winding and secondary winding, it can be wound around the middle limb. Now see, in case of cell type transformer, the core of the transformer, it will be encircle the some portion of the winding. So this is the main difference between core type and cell type. Okay, see here, suppose this is a winding, suppose this is the primary winding, here it is wound, this one is the second winding. Suppose this winding, it will also wound cylindrical. Consider करो आपण ही winding जी आहे, it is also wound cylindrical winding is there. Okay, cylindrical winding is there, and on that winding there are, this one is the limb, one limb एक आहे हा, like that. Again here it is also another one limb. Okay, see, in case of this cell type transformer, these are the winding, it is wound on centrally, or it may be central limb, and around this winding there are core, it should be present. बघा ही वाइंडिंग आहे, याच्या भोवती काय आहे, कोर आहे, बरोबर. बघा या साइडला पण याच्या भोवती काय आहे, कोर आहे, राइट. दॅट मीन्स इन केस ऑफ सेल टाइप, the core of the transformer, it will be surround the some portion of the winding, or it will be surround the some considerable portion of the winding. Okay, so this is the difference between core type and cell type. Getting? लक्षात आलं का? In case of core type, winding encircles the core, म्हणजे कोरच्या भोवती वाइंडिंग आहे. In case of cell type, some portion of the winding, it will be encircles by the core, म्हणजे काही पोर्शन वाइंडिंगचा कोरनं काय केलं आहे, encircles केले और सराउंड्स केलेलं आहे. ओके, गेटिंग डिफरन्स? Hello?
Yes, sir.
Okay, so this is the main difference between core type and cell type, and according to this construction feature, there are these two types of transformer, that is cell type and core type. Ha main difference आहे. Second difference is that in case of core type transformer, the primary winding, it will be wound on the one limb, secondary winding, it will be wound on the second limb. In case of cell type transformer, both the primary winding and secondary winding of the transformer, it will be wound on the same limb. बरोबर? लक्षात येते? Hello?
Yes, sir.
that means it will be wound on the same limb. एकाच लिंब वरती, म्हणजे इथं जो काय सेंट्रल लिंब आहे, त्या सेंट्रल लिंब वरती प्रायमरी वाइंडिंग पण आहे, सेकंडरी वाइंडिंग पण आहे. ओके, so this is difference between the difference between the core type and cell type. Now again, in case of cell type transformer, the coil are form wound but multi-layer disc type. Okay, याच्यामध्ये ज्या काही coil यूज केलेल्या आहेत, so the coil, it will be used in case of this cell type transformer. It is again a form wound but multi-layer disc type. या ज्या काही coils असतील, या multi-layer disc type असतील. Okay, so I think you people understood the word disc. Disc is nothing but disc type. Okay, disc type winding is there, or disc type coil is there, having an multiple layer. I think you people seen in case of your इलेक्ट्रिसिटी पोल वरती आपण एक इन्सुलेटर यूज करतो, बरोबर. सो डिस्क टाइप ऑफ इन्सुलेटर माहित आहेत का? डिस्क टाइप ऑफ इन्सुलेटर, डिस्क म्हणजे आपल्या थोडक्यात एक डिस्क असेल, त्याच्या भोवती दुसरी डिस्क, म्हणजे मल्टिपल लेयर ऑफ दॅट डिस्क, त्या डिस्कचे मल्टिपल लेयर असतील. सो सपोज इफ you people seen the transmission line, in case of high voltage transmission line, there are multiple discs, it can be used as a insulated material. म्हणजे पोल पशी जे काय आपण पोलच्या जवळ आपण इन्सुलेटेड प्रोव्हाइड करतोय, इन्सुलेशन, तिथे डिस्क असतात, बघितलेत का कधी? हॅलो, हॅव यू सीन? बघितलेत का?
Yes, sir.
So these are the disc. That means these are the insulator disc. I think you people studying this insulator, that is type of insulator in the power system. Okay, so these types of insulation, so pivot type of disc or pivot type of insulator मध्ये आहेत ते. So these are like as a disc. So this winding, it will be like a disc. Okay, and there are multiple discs. It can be wound as a primary, as a secondary. Okay, in the form of pancase or in the form of package. Okay, एका पॅकेजच्या फॉर्म मध्ये किंवा पॅकेजच्या फॉर्म मध्ये मल्टिपल डिस्क काय केलेले असतात, एकावरती एक अशी वूंड केलेली असेल, राईट. सो अँड इट विल फॉर्म्स वन primary winding, similarly for secondary winding. Okay, now paper, it is used to insulate the different layer of the multi-layer disc. या मल्टिपल लेयर मधल्या डिस्क मध्ये, सपोज इफ वी आर कन्सिडरिंग दिस इज वन डिस्क, like this one is the one disc. Okay, like that अशा डिस्क आहेत त्याच्यावरती. So these discs are also insulated from each other. Okay, त्या डिस्क ज्या आहेत, this is also insulated from each other by using a paper type of insulation. Okay, पेपर टाइपचे इन्सुलेशन यूज करून आपण काय करतो, त्या इन्सुलेट करतोय. द होल वाइंडिंग कन्सिस्ट ऑफ डिस्क स्टॅक्ड विथ इन्सुलेशन इन बिटवीन, स्पेस बिटवीन दॅट कॉइल. कॉइलचा जो काही स्पेस आहे त्याच्यामध्ये इन्सुलेशन प्रोव्हाइड केलेलं असेल, दॅट इज इट इज स्टॅक्ड बिटवीन इन्सुलेशन. These insulation space from the horizontal cooling and insulating duct. Okay, so these are the insulation space. So this insulation space, it will forms a horizontal cooling. त्याच्यामध्ये दोन डिस्कच्या मध्ये इन्सुलेशन आहे, so that it will forms a horizontal म्हणजे horizontal type ला काय होईल, horizontal type there is a cooling or there is a space, त्याच्यामध्ये स्पेस राहील, so that it will provide a cooling. Okay, and it will insulating a duct, cooling and insulating duct. It will be like as a cooling or it may be insulating duct. Such a transformer may have the shape of simple rectangle. असे जे काही ट्रान्सफॉर्मर आहे, that is cell type transformer. It is this cell type transformer having a shape of simple rectangular or may also have a distributed form. Both design are shown in this figure, that is core type and cell type. So this is the cell type transformer and this one is the core type transformer, and there are mirror difference, that is rear difference between core type and cell type transformer. Cell type आणि core type मध्ये rear difference आहे, so that is construction difference and winding wound difference, whether it is disc type, whether it is form wound, or it may be it is a circulator or cylindrical type. Okay, so this is nothing but the cell type transformer and the core type transformer. So these are the two types of transformer according to the construction, Okay, getting लक्षात आलं का? Hello.
Yes, sir.
Okay, now we will discuss next one. Similarly, as I have told that there are some types of transformer, that is according to construction there are two types we have already discussed, that is core type and cell type. Second one is that it is nothing but according to voltage level, there are again two types of transformer, that is step up transformer and step down transformer. बघा इथे दिलेले type according to voltage level, there are step up transformer, step down transformer. According to phasing, that is single phase and three phase transformer. And then according to application, these two types are depends upon application. According to application, there are power transformer and distribution transformer. And according to instrument or the measuring type, there are two types of transformer, that is current transformer and second one is that potential transformer, that is CT and PT, current transformer and the potential transformer. Okay, current transformer and potential transformer. Now we will see one by one. Okay, So these are the some types. If the question it may be asked, classify the transformer, then you should be answerable to classify these different types of transformer, like according to construction 2 types, according to voltage level 2 types, according to phasing 2 types, according to application 2 types, and according to measuring instrument there are 2 types. Like that, you people should be ready to tell that classification of the transformer. Okay, now do you know that the step up transformer and step down transformer? So in case of step up transformer, these types of transformer, it is categorized on the basis of number of turns used in the primary winding and secondary winding. Secondary winding ला आणि primary winding ला किती number of turns use करतोय? So depends upon that, we are calling it as a step up and calling it as a step down. Okay, see, suppose in case of step up, what is mean by step up? Whether the voltage in the secondary will be increases or decreases? Increases. So do you know that according to transformation ratio, आपण आता transformation ratio पण बघितलंय. If the voltage in the secondary side, it will be increases, that is V2, it will be greater than that of V1. V2, it will be greater than V1. Okay, so that means N2, it is greater than N1. बरोबर ना? V2 is greater than V1, that means N2 is greater than N1.
Yes, sir.
Right, that means if the secondary side voltage, it will be increases, we can call it as a step up as compared to that of primary. Primary पेक्षा जर secondary side से voltage increase होत असेल, that means we are doing a step up voltage, or we are increasing the voltage. So at that situation, how this voltage it will be increases? Do you know that it is depends upon number of turns. Number of turns वरती depend रहे. So that number of turns in the secondary side, it should be greater than that of number of turns in the primary side. That is N2 is greater than N1, and then we can call it as it is a step up transformer. So see, step up transformer, it is a low voltage high current AC into high voltage low current AC. बघा, मी डेफिनेशन मध्ये सांगितलं होतं, it is a low voltage high current AC. Step up transformer, it will be transfer okay, see, step up transformer, it will be transfer a low voltage and high current. So see what I am telling. काय ट्रान्सफर करते हैं ट्रांसफॉर्मर? इट विल बी ट्रांसफर अ पावर फ्रॉम प्रायमरी सर्किट टू सेकंडरी, और पॉवर फ्रॉम वन सर्किट टू सेकंड सर्किट. एका सर्किट पासून दुसऱ्या सर्किट कर काय करते? पॉवर ट्रान्सफर करते. ओके, हाउ इट विल बी ट्रान्सफर? वेदर पॉवर इनक्रीज और डिक्रीज, मी सांगितलं होतं पॉवर ऑल्सो रिमेन्स कॉन्स्टंट. दॅट मीन्स, सो इफ देयर आर नो लॉसेस, इज देयर अ, जर नो लॉसेस असेल, दॅट मीन्स आयडियल ट्रान्सफॉर्मर इज देयर. सो द पॉवर इन द बोथ द साइड रिमेन्स सेम. Okay, so see, if the primary side having a low voltage, primary side ला जर low voltage असेल, primary side it is having a low voltage, at that situation current at the primary side should be high. Okay, and the secondary side, if we are step upping the voltage, that means voltage increases but the current value should be low. So see, it will transfer a low voltage high current AC into a high voltage low current AC. So this one is the MCQ question, that is high current high voltage low current AC system. ते काय करते? ट्रान्सफर करते वन सर्किट पासून दुसऱ्या सर्किट कडे. सो फ्रॉम लो व्होल्टेज हाय करंट टू high voltage low current, or it may be vice versa. Okay, so in these types of transformer, number of turns in the secondary side, it should be greater than that of number of turns in the primary winding. That is V2 is greater than V1, and the voltage is raised on the output side, is known as step up transformer. जर secondary side से output side से voltage increase होत असेल किंवा rise होत असेल, we can call it as a step up transformer. Now opposite to that of step up transformer, there is a step down transformer. Opposite to that of step up transformer, the step down transformer is there. Okay, see, in case of step down transformer, the secondary voltage, it should be less than that of primary voltage. That is, secondary voltage V2, it is less than V1. That means the primary number of turns, it should be greater than secondary number of turns, or N2 it is less than N1. Okay, so secondary turns, it is less than that of primary turns. So we achieve the step up, or sorry, we achieve the less voltage as compared to that of primary, or we are step downing that voltage. Again, we are doing the step down. That means we are transferring the high voltage low current power to the low voltage high current power, right? No, that means P is equals to V into I. Power P is equals to V into I. If the ideal transformer power P is equals to V into I, that is V1 into I1 on the primary or the first side, on the second side V2 into I2. So if to maintain this ratio constant, that means power remains constant. If primary voltage we are increasing, the primary voltage and the primary current, secondary voltage and the secondary current. So if the secondary voltage it is increasing, to maintain the value of power, the current should be decreases. Or if the secondary voltage we are decreasing, that is V2 decreasing, that means secondary current I2 should be increasing. Okay, that means high primary voltage with a low current into a low voltage and high current. It is nothing but step down. It is also MCQ point of view. With this type of transformer, the number of turns in the primary winding, it is greater than that of secondary. That is V2, it is less than V1. And we can call it as a secondary voltage. It will be less than that of primary. So that we can call it as a step down transformer. So these are the two types of transformer. And it is depends upon number of turns used in case of primary winding and secondary winding. Secondary winding la आणि primary winding la किती number of turns use केले त्याच्यावरती different आहे. So these are the two types of the transformer. Again, next one type of transformer, it is nothing but power transformer. That is power transformer. So see, the power transformer, it will be generally used at the generating station. All of you first of all keep in mind, power transformer, it is always usually at the generating station, and the distribution transformer, it is used at the consumer level, or it may be load side. Okay, see, so the power transformer having a rating, more rating as compared to that of distribution transformer. Distribution transformer ला compare करता power transformer चे rating काय असेल, more असेल. So the power transformer having a rating near about 400 kVA, having an 200 kV, 110 kV, 66 kV and 33 kV. They are mainly rated about 200 MVA. So MVA rating of the transformer, about 200 MVA rating transformer, it is the power transformer. Okay, and mainly installed at the generating station and the transmission substation. These power transformers should not be installed at the distribution station. Distribution station मध्ये आपण install करत नाही. So for it is used to step up the voltage at the point of generating station, and it is used to step down the voltage at the point of transmission system. Okay, and do you know that the power, it should be transmitted always in the high voltage, because the cost requirement as well as economical reason, the power should be transmitted in the high voltage. And in India, the maximum voltage should be transmitted. That means maximum voltage transmitted in India. What is that value? माहिती आहे कोणाला? मॅक्झिमम व्होल्टेज किती आपण ट्रान्समिट केलेलं आहे? 765 ना?
Yes, sir.
765 kV. Okay, maximum voltage, that is maximum transmittable voltage, it is 765 kV in our India. Okay, and normally the generation of the electricity always it is in 11 kV. Okay, now to step up this voltage from 11 kV to 765 kV, so we required one transformer. आपला ट्रान्सफॉर्मर पाहिजे ना स्टेप अप करण्यासाठी. 11 kV जनरेट झालेलं व्होल्टेज जे आहे ते मी 765 किंवा 400 kV 200 kV 110 kV ला मला काय करायचं स्टेप अप करायचं. सो दॅट वी रिक्वायर्ड अ पॉवर ट्रान्सफॉर्मर. ओके, नाउ this power transformer it is generally designed, this power transformer it is generally designed for a maximum efficiency of 100%. okay, so हे जे काय power transformer असेल it is generally designed having an efficiency 100%. they are large size transformer as compared to that of distribution transformer. distribution transformer ला compare करता त्याची size काय असेल large असेल. At a very high voltage, the power cannot be distributed to the consumer directly. आता high voltage ची power आहे suppose 400 kV. Whether there is a consumer or the consumer end having an 400 kV. कंझ्युमर आहेत का, युजर असतील का याचे 400 kV चे 765 or 400 kV? No. So user normally suppose we are using our domestic appliances किंवा आपल्या विलेज मधली किंवा डोमेस्टिक अप्लायन्स जी काही इलेक्ट्रिसिटी लेवल असेल, so it is nothing but near about 230 volt AC, 440 volt for 3 phase, right? Now if some industry it will require a 6.6 kV, some industry it will require a 33 kV, some industry it will require a 11 kV. So that we are step downing that to 11 kV that consumer need. म्हणजे कंझ्युमरला जेवढी गरज आहे त्या गरजेनुसार आपण काय करतो त्याला डिस्ट्रीब्यूट करतोय, लाईक स्टेप डाउन करतोय. ओके, नाउ दिस ट्रान्समिटेड पॉवर इट शुड बी स्टेप डाउन टू द डिझायर्ड लेवल. म्हणजे कंझ्युमर युजेबल लेवलला ते काय करावं लागेल आपल्याला स्टेप डाउन करावं. अगेन वी यूज अ स्टेप डाउन ट्रान्सफॉर्मर इन ट्रान्समिशन सिस्टीम. ट्रान्समिशन सिस्टीम मध्ये स्टेप डाउन ट्रान्सफॉर्मर यूज करतो. द ट्रान्सफॉर्मर इट इज नॉट लोडेड फुल्ली, hence the core loss takes place for the whole day, but the copper loss is based on the load cycle of the distribution transformer. Okay, and if the power transformer is connected in the transmitted network, the load function will be very less as they are not connected at the consumer end directly, but if connected to the distribution network there will be fluctuation in the load. distribution network la connected असेल तर there are fluctuation in the load because there is a fluctuation in the consumer side, or it may be consumer end la fluctuation, right? Now in case of distribution transformer, so distribution level, as I have told that distribution level of the voltage it is nothing but it is near about 230, 440 volt, 3.3 kV, 6.6 kV or 11 kV, and they are rated less than 200 MVA. Okay, that is MVA, mega volt ampere. kVA and MVA, all of you keep in mind. 200 MVA, less than 200 MVA, there are distribution transformer, and it is used for distribution network to provide a voltage transformation in the power system. Okay, by stepping down to the desired voltage level. Desired voltage level where the electrical energy is distributed and utilized at the consumer end. जिथं इलेक्ट्रिसिटीची युटिलायझेशन होईल or electricity it should be used by the consumer. So what is the desired level of that consumer, depending upon that we are step downing that voltage. Okay, and the primary coil of the distribution transformer is wound by enameled coated copper or aluminum wire, and the thick ribbon of aluminum and copper it is used to make the secondary of the transformer which is a high current. बघा आपण काय करतोय, सपोज 11 kV इनपुट असेल त्याचं कन्वर्जन मला 230 वोल्ट ला करायचं आहे किंवा 440 वोल्ट ला करायचं. सो दॅट वी आर स्टेप डाउनिंग द व्होल्टेज. स्टेप डाउनिंग द व्होल्टेज. व्हॉट अबाउट करंट?
Step up.
Current it should be increases, no, that means step up a current, or current it should be high. So to carry that value of current we are using a thick wire. सेकंडरी वाइंडिंग जी आहे त्यासाठी आपण थिक वायर यूज करतो. थिक वायर ribbon of aluminum or copper it is used to make the secondary of the transformer, which is a high current and low voltage winding, and resin, impregnated paper, and the oil is used for a insulation purpose. And for insulation purpose we are using oil, or it may be a resin type of impregnated paper. It can be used for insulation purpose. Okay, so this is related to power transformer and distribution transformer. Okay, so these all are related to types of transformer. Is there any doubt in these types of transformer? Hello.
No, sir.
Okay. In this way, we will conclude this today's lecture, and we will stop here.